Hello everyone, I am Sarveshwara Kosuri. Today I am presenting my event-driven machine learning feature store client. In modern MLOps, traditional batch processing creates state features, meaning machine learning models make prediction on outdated data. To solve this, I built a real-time event-driven pipeline using Python, Apache Kafka, PostgreSQL, and FastAPI. This system ingests raw users' interactions the millisecond they happen, computes stateful ML features and serves them to models with ultra low latency. Now I'm switching to my IDE. First I'm opening the docker compose.yml file. Let's briefly look at the architecture. The infrastructure is entirely containerized using Docker Compose, which orchestrates Zookeeper, Kafka, PostgreSQL, and our custom FastAPI Python service. In the code, I strictly separated the concerns. We have a background Kafka consumer thread that listens to the raw event topics. A critical feature here is resilience. Highlight the try except block. I'm switching to the consumer.py. I have strictly separated the concern. We have a background Kafka consumer thread that listens to the raw event topics. This is the it is arranged in the tray except block. If malformed data errors, my Pydantic data models immediately catch the validation error. Instead of crashing the thread, the bad data is locked and skipped, ensuring the pipeline never goes down. Before I want to this is the dbmanager.py. The Pydantic data models my Pydantic data models immediately catch the validation error instead of crashing the thread. The bad data is logged and skipped, ensuring that pipeline never goes down. Now I'll run the project. Docker compose. One set. Docker compose. Docker compose only. The all containers are started in seconds. Now I'm checking the logs by feature client. One set. Feature client. Now let's see it in action. I'll spin up the infrastructure using Docker Compose Deep because Kafka and Postgres takes a few moments to boot. I implemented a custom run app.sh entry point script. Point to the terminal log showing waiting for PostgreSQL. As you can see here, my Python applications gracefully waits for the infrastructure to become healthy before it attempts to connect or start the SGA server. Now the FastAPI server and background consumers are fully running. Now I'm opening a second terminal. I'm run the to prove the system can handle high throughput. I wrote a standalone producer script using Confluent Kafka. I'm running it till now. The script is currently blasting 10,000 randomized JSON events, simulating user clicks and purchases into the Kafka broker. It's now it's produced 1,000 messages. as within during the completion of this script, we'll open the another terminal and check. Call command http login state for user file by giving y. Now let's query the REST API to see the results. I'll fetch the user feature for user file. The, the JSON written with the 200 OK response, we can see the user's total activity count and their very last action. An important data engineering concept I implemented here is independencies. Because Kafka guarantees at least once delivery, we might get duplicate elements. I solved this in use PostgreSQL by using a composite primary key and an insert on conflict do update query. This guarantees that even if a network partition causes Kafka to send exact same event twice, our ML features remains 100% accurate. To test the all core requirements, I implemented a test suite code. Now I will execute it. Finally, production systems require rigorous testing. I'll run my Pytest suite inside the container. Wait for the forward pass test to show. As you can see, all unit tests passed, verifying the Pydantic validation states and FastAPI endpoints using mocked dependency. And when I stopped the container, the FastAPI flyspan context manager catches the SIG-term signal, tells the Kafka consumer to explicitly commit its final offsets and shut down the background thread without any memory leaks. Finished the producing the events. Application shutdown completed, exited with 0 because of we run the Pytest rules. Now switching to the GitHub repo. This is how we concludes the project. This is the guidelines to run the project by cloning this repo. That concludes the demo. The entire project, including setup instructions and a Postman connection, is available in my GitHub repository, and the steps setup instructions, how to run this project. Thank you for watching.